Hi, welcome back. Still on the topic sets and operations on sets, we have started dealing with how to represent sets, and one of them will be a very important topic called Venn diagrams. Right. So, without further ado, let's look at what Venn diagram representation is. Now, I'm going to use the textbook. I'm not going to be writing because this is a very short topic and everything that I need is in the textbook, right? Unless otherwise stated, I'll have to write something in the textbook. So stay tuned. Now, what is a set? Now, a set can be represented by any closed figure, such as a rectangle, a circle, and a triangle, right? The diagrams representing sets are called Venn diagrams, right? So a Venn diagram is not only the rectangle box that we see, right? But that rectangular box with other figures is what make up the Venn diagram, right? So the Venn diagram itself has constituents, and that's what we are talking about as the circle, rectangle, circle, triangle, and etc. It's not only the rectangle that we see. Now, the diagrams representing sets are called Venn diagrams, right? Like we said, any diagram representing the set is a Venn diagram. Now, Venn diagrams are therefore pictorial representation. When you say pictorial, it's what from the base word pictures or shapes or figures of the sets. Now, example, we have set A constituting or comprising 2, 4, 6, 8. We have B, A, B, C, D, E, right? And we have C, 1, 2, 3, right? Can be represented by diagrams below. So set A is in this form. We have dot 2, dot 4, dot 6, dot 8, right? A figure or a number or an element of a set in a Venn diagram is represented with the intro or the prefix figure of what? Dots. A dot. So we see dots in each of the elements in the shapes. So dot. The same thing is applicable to B and applicable to C. So take note of the dots. Now we will talk about them briefly. The Venn diagram also helps you to give a clearer picture of the relationship between one set and another. So we have figure 1.2, right? 1.2, we have 1.3, and then we have etc., right? So don't worry. Now, in a Venn diagram, the universal set is represented by a set of points in a rectangle, and every subset is represented by a circle, right? Every subset is represented by a circle. So dot something, dot something, dot something. That's what we mean. But we will talk about it mainly later. So this is just a brief introduction. When we talk of a Venn diagram, we have something like this. I know you are aware of this, but let's take them small, right? Sometimes this sort, sometimes this sort. So this is what we are talking about. So this is just a brief introduction. So stay tuned. Now, let's take it again. In a Venn diagram, the universal set, which is the rectangle, right, and every subset is represented by a circle, right? Now, the points inside the diagram represent members of the elements. We're talking about the points. This point A, point B, point C, point D, point E. These are the elements that we are talking about. Sometimes the diagram can be used to represent a number of members of various sets from which reductions can be made, right? So we'll talk about it later, where we have a union set, disjoint set, yes, a number appearing here, and still appearing here, also appearing here, and appearing here, and appearing here. So that's what we're talking about. This is just a brief introduction, a way of representing sets. So we will talk about them in depth in the subsequent video, right? So let me briefly use this opportunity to talk about this also, as in the subsets of a set. Now, if all members of a set let's say A belong to a set B, right? Then A is said to be subset of B, written as A with a sign, as looking at C, looking as if it's a C figure, right? B, also pronounced as A, is contained in B. So the sign is very important, right? So A with a sign going inward and then coming out, meaning A is what? Contained in B, right? So the reverse can be written B, the sign A. So where the mouth opens to, it means that this is contained in that. Where the mouth of that figure opens to, so that is it. Look at it very carefully, right? So this is a matter of watch and learn. That is it. So the symbol this and that mean subset of. Now, in order not to be confused about how to use the symbols, it is advisable to stick to one of the symbols. It's very important. Just stick to what? The regular one, this way. So A, P, mean A is contained in this. If I should write B, A, it means B is contained in that. So look at the sign very carefully. Just stick to one. So it is easier to use this, like I said. For example, if A is equal to the members 2, 4, 6, and B 2, 4, 6, 8, 10, 12, then A, right, is a subset of B, since all members of set A belong to set B, right? And this is not equal sets. This is not equal set. Also, if P is equal to 1 and 3, and Q is equal to 1, 2, 3, 4, then P is a subset of Q. If A is not a subset of B, then we write them as A with a symbol and cross it over, B, cross through. The symbol this with a crossover or cross through means it's not a subset of that. It's as simple as that. So with the example here, then look at it very carefully, right? With the time, I don't want to go too much. You can pause the video and then watch and learn very carefully. So we will see in the next episode where we deal with finding the number of subsets in a set, which is called the power set. So stay tuned, keep learning, like, subscribe, and share. Bye for now.